All right. So, over the past couple of days, we've been talking about exponential functions, what they are, how to determine the key features like the asymptote, y-intercept, um, determine whether it's growth or decay. So, now we're going to talk about how do we write exponential functions from word problems. All right. And we're going to talk about two specific types of word problems. But first, let's review this whole concept of exponential functions. All right, generally we see exponential functions written in the form y equals a times b to the x, where a is our starting point or y-intercept, and our b is our growth or decay factor. If b is greater than 1, then we say it's growth, and if it's in between 0 and 1, we say it's decay. So we have some practice here. All right. So, number one, determine whether this is growth or decay. All right. Looking at this 0.97, it is in between 0 and 1. Therefore, that lets us know we're dealing with decay. All right. Our A is 12 and our B is 0.97. All right. Now, number two, we have y equals 0.53 times 1.25 to the x. That 1.25 is greater than 1, meaning this is growth. Our A is 0.53 and our B is 1.25. I think you can complete 3 and 4. All right. Now that we've talked about exponential functions, what they are, what they look like in general, now we're going to review. Well, actually, we're going to skip down to the first type of word problem, and then we'll come up to this second part, which I know is out of order, but you'll see why in a minute. Okay, so for the first type of word problem, all right, we're still dealing with our form y equals a times b to the x. Let's say in a petri dish, there are 7 bacteria that doubles every hour. And we want to write an equation to represent the situation. Now, what we start off with in the petri dish is 7 bacteria. So that's our starting point, A. All right, and it says it doubles every hour. Well, the number that represents double is 2. So times 2 each hour. Therefore, our B is 2. With this information, we can write an equation 7, or y equals 7 times 2 to the x. So that when we're asked to find how many bacteria are there after 8 hours, all we have to do is plug in for x 8 and then simplify using a calculator. All right, so let's try this thing. All right, when we plug this in, we get an answer of 1,792. Bacteria is how much there are in just 8 hours. All right, so we have 2 examples that you're to complete over here to the right. All right, the first one talks about a ball whose height after each bounce is 2/3 the height of the previous bounce. So see if you can write an equation for that. And then come over here where it says the half-life of caffeine is 5 hours. Find the amount of caffeine left from 300 milligrams of caffeine after 10 hours. See what you can do with that. Feel free to press pause. All right, so for number 11, it says a ball drops from 5 feet. So that lets us know our starting point, or A, is 5. And since the bounce is always 2/3 the previous height, our B is 2/3. So our equation would just be y equals 5 times 2/3 to the x. And if we want to find our height after 3 bounces, it becomes y equals 5 times 2/3 to the 3. And then we plug this in the calculator. And we're left with about 1.5. 1.5 feet will be the height after 3 bounces. All right. So we have what we're looking for here. Now with number 12, the half-life of caffeine is 5 hours. Find the amount of caffeine left from 300 milligrams of caffeine after 10 hours. Well, if we start with 300 milligrams of caffeine, right, so that's our A, has a half-life of 5 hours, and we want to know how much caffeine is left after 10. So the number of half-lives are 2. But the main thing, before we even get there, is to realize that we're talking about half-life. So that means in 5 hours, that 300 milligrams of caffeine will shrink to 150. So the B is 1/2. Okay. So our equation is y equals 300 times 1/2 to the x. That's the first part of this. The second part is, all right, find the number that's left after 10 hours. Well, we know after 5 hours, 300 is going to be divided into 2, or half of 300, which is 150. And then after 5 more hours, that 150 will decrease by a half as well. All right, so in order to determine this, we just say y equals 300 times 1/2, and that'll be 2. That's 2, because there are 2 half-lives, which simplifies to 75 milligrams in 10 hours is how much caffeine is left. All right, we're done with the first type of word problem. That one is pretty straightforward. You just have to know the double means 2, half-life means 1/2. For your B, triple would mean 3. When we talk about the second type of word problem, before we talk about it, we need to review how do we change percent to decimal.